Through the precision optics of submarine I-36's periscope, Lieutenant Commander Takeshi Matsumura witnessed something that would fundamentally challenge everything the Imperial Japanese Navy believed about conducting modern warfare across the vast Pacific theater. His submarine lurked just outside the American anchorage, maintaining careful depth and distance, and what appeared before his trained eyes seemed completely impossible according to every single assessment Tokyo's naval staff had made regarding American naval capabilities and limitations. The harbour contained far more than simply warships resting at anchor awaiting orders. Matsumura found himself staring at what could only be described as a complete industrial metropolis, somehow floating upon the ocean waves. His breast pocket notebook would soon fill with detailed sketches and careful observations, destined to send profound shockwaves through the highest levels of Japanese naval command when his report reached headquarters. The periscope revealed 6 enormous floating installations, each one individually dwarfing any dry dock facility existing anywhere in the Japanese home islands. One of these massive structures currently held the battleship USS Alabama, lifted entirely clear of the water as if by some giant's invisible hand, while hundreds of workers and their heavy equipment swarmed across her exposed hull like industrious insects on a carcass. Another structure simultaneously cradled a pair of heavy cruisers undergoing major repairs. The Americans had accomplished what seemed utterly unthinkable to Japanese strategic planners. They had transported their entire shipyard infrastructure directly into the war zone itself, bringing their industrial might to the battlefield. That evening, when Matsumura carefully transmitted his encrypted report back to headquarters through the submarine's radio equipment, he composed words that would plague Japanese naval strategy and planning for the remainder of the conflict. The enemy repairs their damaged vessels at a pace that exceeds our ability to inflict damage through kamikaze operations and conventional attacks combined. This situation transcends conventional naval warfare entirely. We face a mathematical equation that cannot be solved in our favor through any tactical excellence or fighting spirit. The massive installations Matsumura observed through his periscope belonged to the Auxiliary Floating Dry Dock series, manufactured in separate sections across multiple American shipyards on both coasts, before being towed thousands upon thousands of miles across the Pacific Ocean for final assembly, like enormous steel jigsaw puzzles. Consider AFDB-2 as a single representative example of American engineering ambition. This behemoth stretched 927 feet from bow to stern and possessed the capability to lift 90,000 tons of displacement completely clear of the water. When operating at full capacity with its assigned complement of 600 trained personnel, this single floating installation contained complete machine shops with precision equipment, operational foundries capable of casting replacement parts, comprehensive electrical repair facilities with specialized technicians, and storage capacity for 65,000 gallons of fuel oil to service ships. The dock generated its own electrical power through onboard generators, distilled fresh water from seawater through desalination equipment, and operated with efficiency matching any major stationary naval shipyard facility on the American mainland. What remained completely hidden from Lieutenant Commander Matsumura's periscope view would have shattered Japanese naval doctrine even more completely had he known. Scattered strategically across the vast Pacific theater were 7 major advanced base sectional docks and 31 smaller auxiliary floating facilities, effectively transforming every captured coral atoll into a potential duplicate of Pearl Harbor's extensive repair capabilities. The ocean itself had become an American industrial zone. 21 days before the devastating attack on Pearl Harbor that would begin the Pacific War, Vice Admiral Osami Nagano stood before his assembled colleagues in the conference room at Japanese Naval General Staff Headquarters in Tokyo, presenting the final operational plans for the coming war with meticulous detail. The numerical calculations appeared absolutely flawless at the time to everyone present. American naval repair capacity centered primarily on 8 major shipyard facilities distributed along the Pacific coast from San Diego to Puget Sound. Mare Island facility in California could simultaneously handle 4 capital ships undergoing major reconstruction work. Puget Sound Naval Shipyard up in Washington state could manage 3 such massive vessels at once. Pearl Harbor's facilities, despite being the closest American installation to the anticipated primary war zone, could perhaps handle 6 major repair operations, occurring simultaneously at maximum capacity. The arithmetic seemed to favor Japanese strategic planning assumptions overwhelmingly. If Japanese naval and air forces could successfully damage or completely sink 20 American capital ships during the initial 6 months of intensive operations, conventional wisdom and historical precedent suggested the Americans would require at least 18 months to complete all necessary repairs and construct replacement vessels. Any severely damaged ship would need to steam 3,000 miles back to Pacific Coast facilities for major reconstruction work that could not be performed at forward bases. The journey alone consumed 2 weeks in each direction under normal steaming conditions, effectively removing vessels from active combat operations for months at a stretch and depleting American fighting strength. Admiral Isoroku Yamamoto, despite harboring significant personal reservations about initiating war against the United States and her industrial capacity, had nonetheless approved these numerical estimates as the best available intelligence. His trusted operations officer, Commander Kameto Kuroshima, had prepared exhaustively detailed charts demonstrating American industrial capacity in precise quantifiable terms. The United States had produced 1.5 million tons of merchant shipping during the calendar year 1941. Japan, by comparison, produced 400,000 tons during that same 12-month period. But naval construction operated under fundamentally different constraints than merchant shipping, Kuroshima argued persuasively to the assembled staff officers. Warships demanded specialized construction facilities built over decades, highly skilled workers trained in specific trades through years of apprenticeship, and particular materials not easily substituted with civilian alternatives. The critical bottleneck constraining American naval power would inevitably be available dock space and repair facilities with trained personnel, not the raw industrial power that everyone freely acknowledged America possessed in overwhelming abundance. Nobody seated in that Tokyo conference room had imagined the Americans would simply construct entirely new shipyards from scratch and then float those complete shipyards directly to the battle zones where they were needed most. The origin story of American floating dry docks began with commercial necessity and civilian engineering rather than military planning and strategic vision. Back in 1927, the United States Navy commissioned its first self-propelled floating dry dock, designated YFD-2 in the official records. Unlike traditional permanent dry docks laboriously carved from solid granite and poured concrete over years of construction and millions of dollars of investment, floating dry docks operated on straightforward ballast principles that any experienced sailor understood instinctively. Pump water out from the ballast tanks distributed throughout the structure and the entire dock rose toward the surface. Flood those same tanks with seawater and the dock sank beneath the waves to rest on the harbour bottom. A damaged ship could sail directly over a submerged dock previously positioned on the harbour floor, after which powerful pumps would expel the water and lift the entire vessel completely clear of the surrounding water for comprehensive hull repairs and maintenance. By 1940, as war clouds gathered, naval strategic planners in Washington realized this basic technology, when scaled up massively and made genuinely mobile for ocean transport, could effectively eliminate geography as a fundamental constraint in naval warfare operations across the vast Pacific. The Bureau of Ships initiated an extraordinarily ambitious program that seemed impossible even to experienced American engineers with decades of shipbuilding experience. They would construct floating dry docks large enough to handle the largest battleships in the fleet. These facilities would be built in transportable sections specifically designed for ocean towing across thousands of miles. The design specifications required them to operate completely independently in remote locations thousands of miles from any established bases or support infrastructure. The Advanced Base Sectional Dock Program represented American industrial organization operating at its most audacious scale and most ambitious vision. Section A of each complete dock would undergo construction at Everett Pacific Shipbuilding Facilities in Washington State. Sections B and C would come from Chicago Bridge and Iron Facilities in California. Sections D through G would be manufactured at Mare Island Naval Shipyard using government facilities. Each individual section, when completed, weighed 3,850 tons and measured 93 feet in length, 165 feet in width, and 75 feet in depth from deck to keel. 10 complete sections, carefully welded together on site, would create a floating dock capable of lifting an entire Iowa-class battleship completely clear of the ocean surface. The engineering challenges appeared genuinely insurmountable at the outset to conservative engineers. Each section needed sufficient structural strength to withstand Pacific storm conditions during the long ocean towing journey that might last weeks, yet required such precise manufacturing that individual sections could be welded to neighboring sections with tolerances measured in mere millimeters for perfect alignment. The ballast systems distributed across all 10 sections needed to operate in perfect hydraulic synchronization during lifting operations to prevent catastrophic stress. The docks required fully equipped machine shops capable of manufacturing virtually any replacement part needed, from massive propeller shafts weighing tons to precision gun barrels requiring exact tolerances. Commander Tamachi Hara, serving as captain of the destroyer Shigura, witnessed American repair capabilities firsthand during combat when his vessel engaged United States naval forces near Tulagi during March 1943. In his detailed post-war memoir, he recalled with lingering disbelief and frustration how his ship had successfully damaged the cruiser USS Helena with a direct torpedo hit that should have removed her from action. Japanese Naval Intelligence Assessment reported she would require a minimum of 6 months in a major stationary dry dock facility for proper structural repairs. 3 weeks later, against all reasonable expectations, Helena appeared in aerial reconnaissance photographs at Tulagi, completely operational with all her guns firing at incoming Japanese aircraft as if nothing had happened. Hara and his fellow officers simply could not understand what they were witnessing with their own eyes. Where was the massive dry dock facility that must have accomplished such impossibly rapid repairs? Their extensive reconnaissance showed only empty ocean and small coral islands physically incapable of supporting major shipyard operations or heavy equipment. What Hara didn't know and couldn't have guessed was that Helena had been repaired by ABS-D1, assembled at Espiritu Santo just weeks before the engagement specifically for this purpose. The mobile dock had lifted the 10,000-ton cruiser completely out of the water using its ballast systems, repaired the 20-foot gash torn through her hull plating by the torpedo, and returned her to full combat service in just 19 days of intensive around-the-clock labor. The identical repair work at Yokosuka Naval Arsenal in Japan would have consumed at least 4 months of labor by skilled workers. Captain Hara's profound confusion reflected a fundamental conceptual misunderstanding that plagued Japanese naval planning and intelligence assessment throughout the entire Pacific War. Japanese strategists conceived of naval bases as permanent fixed installations with extensive facilities built gradually over many decades of peacetime investment and continuous improvement. Yokosuka Naval Arsenal, Japan's premier facility and source of national pride, had been under continuous construction since 1866, nearly 80 years of steady development. The Americans had created equivalent industrial capability in 6 months of intensive wartime production, and then simply floated that capability directly to the front lines of active combat operations. Admiral Chester Nimitz grasped immediately and intuitively how floating dry docks fundamentally transformed the basic arithmetic of attrition warfare in ways that favored American strategy. In a carefully worded memorandum addressed to Admiral Ernest King and dated January 15, 1943, Nimitz wrote with his characteristic clarity and precision that the availability of floating dry docks in forward areas fundamentally altered the correlation of forces between the two navies in ways Japanese planners had not anticipated. A damaged ship repaired in 3 weeks at Ulithi versus the same ship requiring 3 months for equivalent repairs in San Francisco represented a 4-fold multiplication in available force strength for any given number of hulls in the fleet. The mathematical advantage compounded exponentially across an entire fleet of hundreds of ships. The Japanese High Command discovered this new operational reality gradually through repeated bitter experience in battle after battle. The Battle of Santa Cruz in October 1942 had inflicted what appeared to be severe damage on the aircraft carrier USS Enterprise. Japanese naval intelligence carefully estimated a minimum of 6 months would be required for proper repairs at a major shipyard facility with full equipment. Enterprise reappeared in active combat operations after just 30 days, having been repaired at New Caledonia by the destroyer tender USS Vestal, working in close conjunction with advanced base facilities specially positioned there. Rear Admiral Matome Ugaki recorded his mounting bewilderment in his personal diary entries. The enemy's repair capabilities exceed our intelligence estimates by factors we cannot explain through any reasonable calculation or assumption. Ships we confirm as severely damaged through direct observation by our pilots return to battle before our own lightly damaged vessels even complete repairs at home facilities with full resources. Something fundamental in our basic understanding must be profoundly incorrect. By early 1943, the United States Navy operated an extensive network of floating repair facilities that systematically transformed the entire Pacific Theater into what amounted to an American maintenance highway stretching from California to the forward combat zones. Advanced base sectional docks operated continuously at Espiritu Santo, Ulithi, Leyte Gulf, and Manus Islands. Smaller floating dry docks serviced destroyers and submarines at dozens of additional locations scattered strategically across thousands of miles of ocean. The construction statistics revealed Japan's increasingly hopeless strategic position in stark numerical terms that could not be disputed. Mare Island Naval Shipyard alone produced multiple complete ABSD sections, while simultaneously constructing new destroyers and cruisers on adjacent building ways without any reduction in pace. The shipyard employed 46,000 workers operating 3 complete shifts, maintaining 24-hour daily operations 7 days per week. In just 18 months of intensive wartime production, Mare Island alone produced more total floating dry dock capacity than Japan's entire permanent dry dock infrastructure had accumulated over 80 years of continuous naval development and investment. Lieutenant Commander Haruki Iki, serving as a naval architect at Yokosuka Arsenal with extensive technical training, conducted a detailed analysis of American repair capabilities in early 1944. His comprehensive report calculated that American floating dry docks deployed across the Pacific Theater could simultaneously repair 18 capital ships, 36 cruisers, and over 100 destroyers at any given moment. Japan's entire domestic repair capacity could handle 6 capital ships, 12 cruisers, and 40 destroyers. More critically, from a strategic perspective, Iki identified what he termed the multiplication effect of forward repair capabilities positioned near combat zones. A ship damaged at Leyte Gulf and repaired at nearby Ulithi returned to active combat in approximately 1/4 the time required for a ship forced to sail thousands of miles back to Japan for equivalent repairs. His final conclusion was stark and unambiguous in its implications. We are fighting an enemy who brings his entire homeland industrial capacity directly to the battlefield itself. We cannot sink ships at a rate faster than they repair them and return them to service. This is not a war we can win through conventional attrition strategies. The floating dry docks achieved their first spectacular public demonstration during the American invasion of Kwajalein in February 1944. The battleship USS Maryland absorbed direct kamikaze hits that tore a massive 40-foot hole through her heavily armoured deck. Traditional naval doctrine developed over decades would have immediately dispatched her back to Pearl Harbor or even San Francisco, effectively removing her from combat operations for many months of repairs. Instead, Maryland sailed just 240 miles to nearby Majuro Atoll, where AFDB-2 waited patiently at anchor. This massive dock, under the capable command of Commander Joseph J. Rochefort, not to be confused with the famous intelligence officer Commander Joseph Rochefort, who had broken Japanese naval codes before the pivotal Battle of Midway, submerged its entire deck below the waterline, allowing Maryland to carefully position herself directly over the massive keel blocks. In just 4 hours of careful work, powerful pumps expelled 8 million gallons of seawater, raising the 45,000-ton battleship completely clear of the ocean surface for inspection and repair. Captain Yoshitake Miwa, commanding submarine 184, observed the entire operation carefully from periscope depth and immediately transmitted a detailed radio report back to Tokyo headquarters. Maryland entering floating dock at Majuro. Extensive damage clearly visible to hull and superstructure. Estimate minimum 3 months required for proper repairs based on damage assessment. 3 weeks later, to Japanese amazement, Maryland departed Majuro under her own power with all systems functioning. Full combat capability appeared completely restored to pre-war operational standards. The Americans have made both time and distance strategically irrelevant factors in naval warfare. Commander Mochitsura Hashimoto of Submarine the 58 later wrote extensively in his memoirs about the profound frustration of Japanese submarine operations during the war. We would successfully attack an American aircraft carrier or battleship, carefully observe the damage inflicted through the periscope, calculate the many months that would be required for proper repairs based on our experience, only to encounter that identical ship just weeks later operating at full combat capability as if nothing had happened. It felt like fighting against mythical creatures from ancient legends that possessed the supernatural ability to heal their wounds almost instantaneously. AFDB-7, operating at Leyte Gulf, demonstrated complete overhaul capability with the carrier USS Franklin after she absorbed devastating kamikaze damage in March 1945. Franklin had suffered the most severe damage of any United States aircraft carrier to survive the entire war. 807 sailors had died in the initial attack and subsequent fires. Standard peacetime procedure would have written Franklin off as a constructive total loss not worth the extensive repair effort and resources. But AFDB-7's crew of 1,000 men included certified specialists in virtually every aspect of ship construction and repair. They operated continuous shift schedules that never stopped, working around the clock in all weather conditions. Master Chief Petty Officer William Delaney later provided sworn testimony about the intensive repair operation. "We essentially rebuilt that ship from the inside out," he stated plainly. In a stationary yard with full facilities and unlimited time, it represented a 6-month job minimum under the best possible conditions. We completed it in 11 weeks while operating in an active combat zone under regular air attack and primitive conditions. Lieutenant Commander Sadao Kusaka flew detailed reconnaissance missions over American forward bases throughout the theater. His comprehensive report from April 1944 revealed the strategic shock rippling through Japanese naval intelligence assessment. Observed Ulithi anchorage in great detail from multiple altitudes and approaches. Counted 6 large floating structures previously identified in earlier reconnaissance reports as possible cargo vessels or ammunition ships. Upon much closer examination at low altitude, these are clearly mobile dry docks of unprecedented size never seen before. One currently contains battleship Iowa with her entire massive hull exposed for repair work. American maintenance capacity is not fixed in homeland facilities but has become mobile and deployable. They transport their entire industrial bases with them wherever combat operations require presence. Admiral Soemu Toyoda, who had assumed command of the combined fleet after Yamamoto's death in combat, received these increasingly desperate reports with growing understanding of strategic reality and ultimate defeat. At a staff meeting in May 1944, he presented the unavoidable reality of impending defeat to his assembled senior officers. If the Americans repair their damaged ships 3 times faster than we can repair ours, basic mathematics dictates we must sink 9 of their ships for every single one we lose in combat. This is operationally impossible to achieve. We are losing this war to American floating steel and superior industrial organization, not to their fighting sailors or tactical skill. Each dock section included complete living quarters for its assigned crew, equipped with comfortable bunks, full galleys with modern cooking facilities, and comprehensive medical facilities with trained corpsmen. Seaman First Class Robert Leckie, assigned to AFDB-3 at Manus, described the daily life experience of serving on a floating dry dock in vivid detail. Here we were, thousands of miles from home and family, living on this massive steel structure anchored in a tropical lagoon far from civilization, he recalled years later. We had movie nights with films projected on the dock walls, baseball games played on the dock floor when no ship was currently undergoing repairs. We weren't just repairing damaged ships for the fleet to return to combat. We were living as a floating piece of America transported to the war zone, maintaining our culture and morale. The food quality served on floating dry docks became legendary throughout the Pacific Fleet. While combat ships subsisted on Spam and powdered eggs for months at sea without fresh provisions, the dry docks maintained large frozen food lockers and full operational bakeries with trained bakers. AFDB-2's Thanksgiving dinner in 1944 served 2,000 complete turkey dinners, with all traditional accompaniments to crews of damaged ships undergoing repairs, a remarkable feat. Vice Admiral Takeo Kurita experienced the strategic impact of mobile repair facilities directly during the massive Battle of Leyte Gulf in October 1944. His entire battle plan carefully assumed that damaged American ships would be forced to withdraw thousands of miles for repairs, thereby weakening the invasion force over time through attrition. Instead, damaged vessels simply sailed to nearby mobile repair facilities and returned to combat within days, sometimes hours. Kurita later wrote about his mounting frustration. We would damage an American cruiser with successful torpedo hits we confirmed visually, assume we had eliminated it from combat operations for many weeks, only to face that identical ship just 3 days later firing all guns at us. We were fighting not just the American fleet, but their entire industrial system made somehow portable and brought directly to our doorstep. The most remarkable pre-deployment repair feat occurred with USS Yorktown between the battles of Coral Sea and Midway. Yorktown, severely damaged at Coral Sea with major structural damage that should have taken months to repair properly, arrived at Pearl Harbor on May 27, 1942. Admiral Nimitz gave the repair crews exactly 72 hours to make her combat ready for the upcoming battle. The ship entered Dry Dock No. 1 on May 28th, and 1,400 workers from Pearl Harbor Naval Shipyard laboured continuously around the clock without pause or rest breaks. Yorktown sailed on May 30th with her flight deck patched and her boilers operational. The ship was combat-capable, though not fully repaired. Japanese intelligence remained absolutely convinced Yorktown was still safely under repair at Pearl Harbor, completely out of action for months. When Japanese pilots at Midway reported attacking a third American carrier, Admiral Nagumo's staff simply couldn't believe the reports were accurate because their calculations showed only 2 were possible. Lieutenant Joichi Tomonaga reported before his death that the Americans possessed 3 operational carriers, where Japanese calculations indicated only 2 were possible in the battle zone according to all intelligence. By mid-1944, American floating dry docks had systematically transformed the entire Pacific Ocean into what amounted to an American maintenance highway stretching from California to Japan. A ship damaged at Formosa could be repaired at Leyte faster than we can repair a ship damaged at Leyte, and successfully returned to Sasebo home port, wrote one increasingly frustrated Japanese staff officer in his reports. We are fighting an enemy who has made geography completely irrelevant to naval operations and logistics. Between 1942 and 1945, The United States produced 7 complete advanced base sectional docks, 31 auxiliary floating docks, and scores of smaller auxiliary repair docks. The combined total lifting capacity exceeded Japan's entire permanent dry dock capacity, accumulated over decades by a factor of 4 to 1. Each ABSD cost approximately $40 million to build and deploy to forward locations, roughly equivalent to the total cost of a new light cruiser including all equipment. Rear Admiral Kizo Kimura captured the profound psychological impact in his personal diary entries. The Americans build floating dry docks the size of city blocks and then casually tow them across the Pacific Ocean as if already certain of ultimate victory without doubt. They are already building the peace and post-war order while we still desperately fight the war for survival. Chief Petty Officer Marcus Thompson, serving as a skilled hull repair specialist on AFDB-2, had completed 18 months of intensive specialized training at Mare Island before deployment overseas. His team of 40 highly skilled welders could repair severe torpedo damage that would have challenged major established shipyards with full equipment. "We became true artists of destruction repair," Thompson recalled in a candid post-war interview. "Destroyer comes in with her bow blown completely off by torpedo hit. We'd fabricate an entire new front end in 5 days, working continuous shifts without stopping. The medical facilities on floating dry docks added unexpected strategic value beyond simple ship repairs. Each major dock included a complete hospital with modern operating rooms and full surgical equipment." Dr. Lawrence Steinberg, serving as Chief Medical Officer on AFDB-1, performed over 200 major surgical procedures during his deployment treating wounded sailors. In November 1944, Submarine I-365 received specific orders to penetrate Ulithi anchorage and attack the floating dry docks rather than focusing on warships as primary targets. The mission reflected new strategic priorities from Tokyo headquarters, desperate to stop the repairs. The submarine was detected and destroyed before reaching Ulithi, becoming one of 6 submarines lost attempting to attack floating repair facilities that year. The only successful Japanese attack on floating dry docks occurred on April 22, 1945. Lieutenant Saburo Shimbo and Ensign Chuhei Okubo, flying at 14,000 feet altitude, mistook empty floating dry docks for capital ships and conducted a determined suicide attack. A follow-up strike damaged ABSD-2's Section G with bomb hits, but the dock's own crew completed all necessary repairs within 3 days using their own extensive facilities and equipment. Commander Masataka Okumiya analyzed the operational failure in his post-war writings. "We could occasionally damage individual warships through sacrifice attacks that cost pilots their lives, but the floating dry docks multiplied across the Pacific like living organisms reproducing themselves. They were not just floating docks, but floating factories that possessed the capability to reproduce themselves and repair each other without returning home." The brutal Okinawa campaign from April to June 1945 witnessed the most concentrated damage ever inflicted on any fleet in naval history. Over 400 American ships absorbed varying degrees of damage from determined kamikaze attacks. A fleet of floating dry docks at Karama Retto operated continuously without pause, sometimes lifting damaged ships while still under active air attack from kamikaze aircraft. Captain Toshiyuki Yokoi, commanding kamikaze operations from land bases, recorded his mounting despair. "Our pilots sacrifice their precious lives to damage American ships, only to see those same vessels returning to combat within mere days. The floating dry docks at Karama Retto repair ships faster than we can organize new attack waves and train replacement pilots. Of 404 ships damaged at Okinawa, 387 were repaired sufficiently to continue operations without returning to permanent bases thousands of miles distant. The destroyer USS Laffey, struck by 6 separate kamikazes on April 16th in one of the war's most intense attacks, was operational again by May 1st. Captain Minoru Genda reviewed captured American planning documents after the war concluded and surrender was signed. They had intended to bring 12 major floating dry docks and 40 smaller ones to Japanese home waters for the anticipated invasion operations. Even if we had damaged half their entire fleet daily through coordinated suicide attacks, they could have repaired ships faster than we could reload our guns with ammunition and organize new attacks. Working with battle-damaged ships meant regularly handling unexploded ordnance and toxic smoke from fires. On AFDB-3, 7 workers died tragically when a weakened bulkhead collapsed during intensive repairs on USS Pittsburgh. Yet morale remained consistently high despite the dangers. The motto of AFDB-2, painted in letters 10 feet high on the dock wall visible to all, read simply, "We keep them fighting." Admiral Soemu Toyoda's post-war interrogation by American intelligence officers identified 3 decisive factors in Japan's ultimate defeat: American submarine warfare destroying merchant shipping, fast carrier task forces projecting power, and floating dry docks maintaining that power. On the third factor, he stated candidly, "Your floating dry docks killed the Japanese Navy as surely as your bombs and torpedoes and submarines. You made time and distance strategically irrelevant factors. You brought your homeland's industrial power directly to our home waters where we could not match it." Between 1943 and 1945, American floating dry docks performed 1,847 major ship repairs and 8,234 minor repairs across the Pacific. They returned 95% of damaged vessels to full combat service within 30 days, an unprecedented achievement. Commander Joseph Rochefort, the brilliant intelligence officer whose code-breaking contributions helped win the pivotal Battle of Midway, offered penetrating insight into the strategic situation. The Japanese thought they were fighting ships and men in a conventional naval war of the past. They were actually fighting our entire industrial system, which we had made portable and deployable across oceans. Every floating dry dock was Detroit and Pittsburgh made manifest in floating steel that could be positioned anywhere we needed it and wanted it. The organizational vision came from forward-thinking officers like Rear Admiral Ben Morrell, who understood that American industrial superiority meant nothing strategically unless projected directly to the point of conflict where it mattered. His vision systematically transformed industrial power from a mere homeland advantage into a deployed weapons system capable of winning battles and wars. Mare Island Naval Shipyard employed 6,000 women by 1943, breaking traditional barriers. Marjorie Muller, one of the first female welders at the facility, worked on ABSD-2 Section F with dedication. "Every perfect weld I made meant American sailors would live and come home to their families," she reflected years later. The Chicago Bridge and Iron Company employed 4,000 African-American workers at its California facility, where they built 3 complete ABSD sections, achieving production rates that exceeded some integrated yards operating under fewer time pressures and with more resources. Admiral Arleigh Burke frequently cited floating dry docks as perfect examples of American innovation and industrial thinking defeating traditional military excellence and warrior culture. The Japanese brought superior training and tactical excellence to the Pacific War initially, he often stated in speeches. "We brought floating dry docks and industrial organization. They made the ocean a battlefield for warriors. We made it a factory floor where industrial power decided final outcomes." Japanese naval attachés had regularly reported on American shipbuilding capabilities throughout the 1930s, but interpreted everything through the lens of their own cultural experience and assumptions. Commander Yoshiro Fujimura personally visited Chicago Bridge and Iron facilities and observed sectional construction techniques firsthand with his own eyes. His official report noted that Americans build industrial plants like children's toys, in sections to be assembled later like playthings. Interesting but irrelevant to proper naval construction requiring years of skilled work by master craftsmen. As the war ended with Japanese surrender, American floating dry docks were still being produced at full capacity without slowdown. AFDB 8 through AFDB 14 were under active construction for the invasion operations of Japan that never occurred due to surrender. The story of American floating dry docks represents two fundamentally different concepts of power and warfare meeting in decisive conflict. Japan conceived power in traditional military terms that had served for centuries: warrior skills, tactical excellence, superior training, fighting spirit, and Bushido code. America conceived power in modern industrial terms better suited to total war: production capacity, repair capability, logistical sustainability, and the ability to project industrial power across vast oceans to any location needed. The Pacific War tested these two competing visions in the most comprehensive and decisive way possible. Once American floating dry docks deployed systematically across the Pacific theater, each one represented the entire American industrial system made mobile and deployable wherever needed. They were Detroit's assembly lines and Pittsburgh's steel mills brought directly to the battle zone itself. Against such industrial might made portable and mobile, no amount of traditional military excellence or warrior spirit could ultimately prevail or achieve victory. Admiral Somu Toyoda's final assessment captures their ultimate strategic significance perfectly. You defeated us the moment your floating dry docks arrived in the Pacific theater in significant numbers. We could sink your ships with skill and sacrifice, but you could raise them again and return them to battle within weeks. They meant you could suffer any losses and continue fighting indefinitely without weakening. The Pacific Ocean itself had become an American lake, not because you controlled it through superior fighting or warrior spirit, but because you could maintain your control anywhere, anytime through industrial power made mobile and deployable. We realized far too late we were not fighting ships and planes and men in traditional warfare, but an entire industrial system that had learned to float across oceans and position itself wherever needed most. That was a war we could never win through courage alone or fighting spirit, regardless of sacrifice.